Hello, this is Patrick at OneCNC West, and what we're going to do in this training video is continue to apply toolpath to our part using OneCNC Mill Expert. Why don't we take a look at applying toolpath to this tapered face? Now, you'll notice that I have our cap geometry turned on, and remember from our last video that the cap geometry is on a layer called caps. If your caps are not turned on, just simply click on the little eye to turn your cap geometry back on. Very good. All right, to apply the toolpath, let's head over to the Command Manager and select our model toolpaths. From there, we're going to select Planar Finish Face. And what you want to do is take your cursor and left-click on the surfaces in which you'd like to apply the toolpath. Once you're finished, you can right-hand mouse click. Very good. Now, the very first dialog box, just like with all of our previous machining operations, is where we can define a tool. We can select a tool from the tool library, or we can manually create a tool. For this example, why don't we select a tool from the tool library? You can access the tool library by clicking on Tool Changer or left-clicking on the tool graphics. I'm going to select Tool Changer, and within the dialog box, the default tab is called Recent. This shows you a list of recent tools that were used, and you can certainly select any one of these if you'd like. However, for this tool, let's select the Library tab. You'll notice that all the tools are categorized into different groups. We're going to be using ball mill, and for this, I want to use a 1/4 inch high-speed ball end mill. I'm going to left-click and then click OK. You'll notice that once we do that, OneCNC automatically calculates the speeds and feeds. And that's simply because inside of the tool library, we have parameters such as diameter, the amount of flutes, and the chip load. All right, I'm going to cancel out of that. You can also overwrite these speeds and feeds if you'd like. So for the RPM, I might type in something like 6,000. For turret position, that's going to be turret position number 5. For feed rate, I'm going to up that to 10 inches a minute. Very good. For tool type, that's a ball end mill. Overall length is 1.5 inches. Flute length at 5/8. That looks good. Diameter at 250 thousandths. I think all this looks good, so let's click Next on that. Our rapid Z-plane is 200 thousandths. I think that looks fine. And remember, that's represented by the red grid here. It's all very dynamic. If I type in, for example, 1 inch, you'll see the red grid hop up there. I'm going to put that back to 200 thousandths. Plunge clearance is where the toolpath is going to start to feed down. That looks good at 50 thousandths. Let's click Next on that. For toolpath angle, I'm going to type in 0 for 0 degrees. That means the toolpath is going to be parallel to the x-axis. If you wanted the toolpath to be parallel to the y-axis, you could type in 90 for 90 degrees. But for this, let's leave it at 0. Now, zigzag minimum clearance, if we were taking lots of individual passes like a climb cut or a conventional cut, the zigzag minimum clearance is the amount the tool is going to feed down along the z-axis at the beginning of each pass. I'm going to leave that set to 100 thousandths. Leave for finish, let's leave that set to 0 because this is going to be a finish pass. And for surface tolerance, let's use the default value of 2/10. For direction, we have 3 different strategies: zigzag, climb cut, and conventional. I'm going to be using zigzag for this. Let's use a constant step over of 20 thousandths and then click Next. For boundary type, there's just one option, and that's called Part. For tool placement position, we can leave this set to none because we've already selected the surfaces that we want to machine. These parameters control the Z envelope, or the extents that the tool is going to be moving along the Z-axis. If you click Automatic Z and you type in a value, for example 50 thousandths, OneCNC will scan the model, add 50 thousandths to the top, 50 thousandths to the bottom, and that will be the envelope that the tool will be constrained along the Z-axis. If you don't want to use Automatic Z, you can uncheck and you can type in whatever values you want. For example, we could type in 0 for Z top, minus 1 inch 300 thousandths for Z bottom, and now the toolpath will be constrained along the Z axis within these parameters. I think all this looks great, so let's click Finished and let OneCNC generate the toolpath. All right, very good. Why don't we take a look now at performing a finish profile operation to the large circular pocket. We no longer need our cap surfaces, so let's head over to the Layers browser and turn off the caps layer by just clicking on the little eye next to the layer name. Very good. Now I can see that I need to create some wireframe geometry to drive the tool against for the profile operation. So I'm going to make sure that my part layer is active. We can see that it's highlighted here. Let's head over to the Command Manager and let's click on our model tools. From there, I'm going to use the option called Extract an Edge. I'm going to take my cursor and just left click on the bottom edge of that circular pocket. Very good. You can see OneCNC has created the wireframe geometry. Now in just a little bit, I'm also going to be profiling the outside perimeter of the part. So for this, I also want to extract wireframe geometry from the bottom of the part. So I'm going to left click on any one of the edges at the bottom of the part, and when I'm done, I can right-hand mouse click. And again, you can see that OneCNC has created the wireframe geometry. All right, very good. Let's perform a profile operation now for that circular pocket. We're going to head over to the Command Manager. We're going to select our stock toolpaths, and from there, let's just use a mill profile basic machining operation. OneCNC wants us now to select the profile. We can take our cursor, and what you want to do is you want to left click where you want the profile operation to start. I'm going to left click, and once we do that, we have these arrows. Now the arrows determine the side and the direction of cut. I want a climb cut on the inside, so I'm going to left click that arrow and then hit the F3 key on the keyboard to select the rest of the geometry. Let's right-hand mouse click, and just like before, the very first dialog box is where we define our tool. Now in the previous machining operation, we selected a tool from the tool library. Why don't we mix things up a little bit, and why don't we manually create a tool for this? This is going to be in turret position number 6. That looks great. For the RPM, I'm going to reduce that to 4,000. For the feed rate, let's reduce that to 30 inches a minute. That looks good. Type of tool is going to be an end mill. For the overall length, 1.5 inches is fine. Our flute length is fine. But for the diameter, I'm going to reduce that to 1/2 inch. Very good. Let's click next on that. Our rapid Z-plane, represented by the red grids, is set to 500 thousandths. I'm going to reduce that to 200 thousandths. Plunge clearance is where the tool starts to feed down. I'll leave that at 50 thousandths. And for the final Z depth, we can select this option called Pick Z, and then take our cursor and snap any one of the vertices at the bottom of the circular pocket. Once we do that, OneCNC will extrapolate that data and place it right inside the final Z parameter. That looks very good at -1 inch, 150 thousandths. Let's click next on that. We have the option to ramp profile, but for this, let's just profile at one level. So we're going to select cut levels. Let's click next on that. Don't need to worry about auto step over. This is for side roughing. We don't need to worry about that. I'm not going to take this in multiple passes, so I'm not going to check rough depths. Leave on side 0 because this is going to be a finished pass. We don't need to worry about the wall taper, so let's click next. Now, within finish settings, this gives you the ability to perform an extra finish pass. Let me quickly explain how this works. I'm going to click back, and if we were to leave, for example, 20 thousandths, if we click next, and then for finishing, select bottom only, that means that OneCNC will perform an extra finish pass and remove this 20 thousandths. So this dialog box is when you want to use the same tool to perform an extra finish pass. In this example, we don't need to do that. I'm going to leave this set to none. Let's go back here and put this back to 0. Very good. All right, so we'll click next, next, and for our lead in style and lead out style, I'm using a lead in arc radius of 200 thousandths with a lead angle of 45 degrees, and I'm using the exact same parameters for the exit values. That's great. Let's click Finish and let OneCNC generate the toolpath. Very good. So here's the toolpath performing a finish pass on that circular pocket. Now let's profile the outside perimeter of our part. To do that, we're going to go back into the Command Manager. Again, we'll select Mill Profile Basic. This time I want to start our profile down here. I'm going to left click the arrow for the direction and side of cut, and again we'll hit the F3 key on the keyboard to select the rest of the geometry. Let's right-hand mouse click, and for defining our tool, why don't we use the exact same tool we used in our previous machining operation. So I'm going to leave all of these parameters alone. I'm going to click Next on that. Our rapid Z-plane, plunge clearance, material top, all that looks good, but we're going to need to change our Z depth. So again, I'll use Pick Z, take our cursor, just snap any vertice at the bottom of the solid model. OneCNC extrapolates that data and pushes it inside of the final Z parameter. And if we want, we can change the value. For this, why don't we change it to -1 inch 300 thousandths? And the reason why I did that is I want this Z depth to match the same Z depth we use for our Z level rough machining operation. I think all this looks good. Let's click Next on that. Again, we'll use cut levels. Next. We can leave all these parameters exactly the same that we used in our previous machining operation. We'll click Next on that. We don't need an extra finish pass. We'll click Next. And again, we'll use the exact same parameters for our entry values and exit values. Let's click Finish and let OneCNC generate the toolpath. Very good. Now, why don't we take our toolpath into toolpath simulation? Let's head over to the NC Manager. We're going to right-hand mouse click on the toolpath group, and from there we're going to select Simulate Rest. Let's use the solid model that we had created earlier, so we're going to use the stock model option. We'll click OK to that and let OneCNC simulate the toolpath. Now, within the toolpath simulation, you can see that I have the speed turned up really high, but I'm going to slow it down when we get to the 3 brand new machining operations that we just added. Okay, so I've slowed the simulation speed down, and now we're taking a look at that planar finish face operation. And notice how that cap geometry is doing a great job of keeping that tool from machining down inside of those counter bores. All right, let's change tools to the end mill. There's the finish profile of the large circular pocket, and now you're seeing the finish profile on the outside of the part. Very good. Now let's talk about the advantages of displaying each tool using a drastically different color. Now within OneCNC, you'll have the ability to change the color palette of the tools that were used. In these previous examples, we've been using the aluminum color palette, and you can see that in the lower right-hand corner. If you left click, you can select different color palettes. Now, one that I typically use is a color palette called Random. Random will use a completely different color for each tool. So let's select Random, and we'll head back over to our VCR controls and restart the toolpath simulation. Now if you look at the very bottom of the screen within the toolpath simulation progress bar, you're going to notice that each tool has a different color. This can be of great benefit when speeding up or slowing down the toolpath simulation. Now, another great benefit of using different colors for the toolpath simulation is that you can make sure that the current tool is removing the proper amount of material. In other words, you can check the current toolpath easily against the previous toolpath. Let me demonstrate. If you take a look at the ball nose end mill performing the Z-level finish machining operation, you'll notice that the toolpath for this ball end mill is purple, and it's easy to compare the purple toolpath to the previous toolpath, which in this case was green. By looking at the purple toolpath and by not seeing any green underneath it, we know that that tool is removing the right amount of stock. All right, that's it for this video. Thank you so much for watching, and I look forward to seeing you in the next video.